We were talking about coming up with a line that best described the trend between the number of egg yolks in a particular recipe and the amount of cholesterol in that recipe. One definition for the line of best fit is the one that has the least error or smallest residuals, or the shortest distances of the observed data to that line of prediction. If we follow this definition, we got the following formulas for slope. B is the correlation times the ratio of the standard deviation of y's over x's, and the intercept, A, is the mean of the y's minus the slope times mean of the x's. So notice we said intercept requires knowing the slope, so we're going to find the slope first. Once we find the slope and the intercept, we can give our final answer in the form of a line. So just for reference, you guys have the data in front of you. Make sure you use the information presented in the table. I'm going to scroll down a little bit so you might not be able to see it. But here we go. First, let's find our equation for the slope. So that's going to be denoted by B. And that formula, just as a reminder, and maybe write it down, it'll help you remember it more as we go on. Standard deviation of y's over standard deviation of the x's. So R, the correlation, here's a reminder from a couple videos ago. Correlation was this value, 0.8328. And then standard deviation of the y's, we defined above, was the 62.25 over standard deviation of the x's, 2.17. So that ratio, 62.25 over 2.17. If you work this out on your calculator, maybe take a moment, pause, take a moment to do that, you should get 23.89, and I'm going to round to 4 decimals to keep this consistent with our work all semester. Nothing magical about 4 decimals, just trying to have a form of consistency as we go throughout. So this is the value of our slope of the best line. Next we need to find A, our intercept. Maybe let me label these steps here. Step 1, find the slope. Step 2, let's find the intercept, A. Reminder of the formula, mean of the y's minus slope times mean of the x's, just grabbing it from right here. So if we look at the top of the page, your mean of the y's is that 81.73 value, minus the slope that we just found, 23.8902, times the mean of the x's, that's a 2.91. So take a pause and just check out at the top, make sure you understand where all these numbers are coming from based on our formula here. And when you work that out, you should get 12.2095, again just rounding to 4 for consistency across the course. And this is the value of our y-intercept. Now notice this is asking for the equation of the line. We've given slope and intercept. We found 2 constants, but we actually need to plug those into our equation of the line. So remember that equation was sort of like the y equals mx plus b, but we're going to rewrite it here as y hat equals a plus bx. So if we translate that here, and we're going to do this in context, so y and x, make sure those are in context of the problem, or in other words, we're actually going to put in words there instead of just y's and x's. So this equation has some meaning to us. So our y variable, if you remember, was cholesterol. And I'm going to put the hat over it because that gives us some meaning, where that means predicted when you read it. So predicted amount of cholesterol, we're predicting cholesterol to be equal to A, that's our intercept we just found, the 12.2095, plus B, that's the slope we found, 23.8902, times X. The X variable in this problem is the number of egg yolks. So this is your final answer to the question. There's a lot of steps involved here. we're trying to come up with the equation of the line. So first we need to define slope, then intercept, and then put it all together for our final answer. Again, importantly, put x and y in context of the problem. So this is what we're looking for as our final answer. All right, let's try some more digging into this problem. And maybe I'll jot down the equation here next for some reference. So just to use our line, if we want to use our line to make a prediction, all we need to do is plug in the x values of interest. So we'll make 3 different predictions here. So the first one is interested in when x is 0 egg yolks, the predicted amount of cholesterol is going to be equal to our intercept, the 12.2095, plus 23, our slope, 0.8902, times 0 egg yolks. So we're actually just plugging in the value for x that we're interested in. So I'm interested in x of 0 egg yolks, so write it down and plug that in. If you plug in 0 here, this whole second term goes away, and I'm left with 12.2095 milligrams of cholesterol. Okay, similarly, we can make a prediction for 1 egg yolk in the recipe. The only thing that changes is we're going to plug in 1 for our x value of interest. And if we do that, we should get something like 35.9997. And then the last one, you see where this is going. If you want to pause and try it on your own, go for it. If we plug in 2 for the number of egg yolks, then we get our predicted amount of cholesterol as 59.8899. Again, some of this, if you rounded differently and haven't been keeping 4 decimal places, you might get something a little bit different. But the main takeaway here, to use your line for prediction, it's as easy as plugging in the x value that you want to make a prediction about. Now the next bit, we're curious about residuals. So if you remember our formula for residual, do a reminder over here. E, we use that notation for error or residual, was what we actually observed, the y from the data set, minus what our line is predicting, this y hat. So what we see and what we predict, we're looking at that discrepancy. That's our definition of residual. So they give us one observation here, the observation of 151. So that is just a normal XY data pair that we are familiar from seeing elsewhere. So to calculate our error here, we need, I'll write it down again to help us remember, we need our observed Y value. So that's this guy, that's our 51. Then we need what the line predicts when x is equal to 1. So remember, x, we need to keep x the same. We're just looking at that vertical distance between our point and the line. So good thing we found that before. When x is equal to 1, the line predicted 35.9997 milligrams of cholesterol. So again, looking at that difference between data point of 51 milligrams when there's 1 egg yolk versus the line predicting about 36 when there's 1 egg yolk. So that discrepancy, if we do the subtraction, will be 15.0003. Notice this is a positive residual, so that means that that point is above the line. Now you might want to pause, try the second one on your own for a moment, and then double check. Make sure you got this. Okay, so here's our XY point. So our residual is the observed Y of 36 milligrams of cholesterol. And then the data, when we use it to fit the best line, the predicted value for 2 egg yolks was up here. This last one, when we plugged in 2, we got 59.8899. And if you do that subtraction, you're going to get negative 23.8899. And you might see this negative and worry, but remember, no need to worry here. That negative simply means the data point falls below the line. All right, let's check out two more main points here, and then we'll pause before going over one additional example. So we've figured out how to calculate the line, how to use the line for predictions and measure errors in predictions. The next thing we need to do is make sure we can interpret all these calculations. So interpreting means we're going to be writing out interpretations. We're not going to be doing any math here, and we're going to look at interpreting two things, the slope and the intercept, and it's very important that our interpretations be in context. So I'm going to do just kind of a quick little example off to the side. Suppose I had an equation y hat is 1 plus 2x. If I plugged in x equals 0, you guys would say y hat is going to be 1, right? Plug in 0 here, that term goes away and I just have 1 left. If I plug in x is 1, y hat's going to be 3. 2 times 1 is 1, plus 1 more gives me 3. Let's do a few more. X equals 2. Y hat is 5. X equals 3. Y hat is 7. If I did x equals 4, y hat would be 9. So our interpretation of the slope is just kind of observing this pattern. Notice what happens is x goes up 1 each time. The prediction goes up by 2 each time. So that's basically our sentence interpreting the slope. As x increases by 1, the predicted y increases by the slope. Now, you might want to think about, what if this was a negative 2? What would happen? Sure, these guys would go down by 2 each time, and our interpretation would be, as x increases by 1, y is going to be decreasing by 2. So, depends on the sign of the slope. So let's write that sentence down generally first, and then we'll put it in context. So slope, in general, we might say something like this. As x increases by 1 unit, okay, so it's always by 1 every time. The predicted, now it's very important you have predicted here, because we're making a prediction of what's going to happen. It's not necessarily going to happen exactly that way. We're talking about an average or predicted behavior. So as x goes up by 1 unit, the predicted or average or expected y will, and I'm going to say increase / decrease. And I'll leave that up to you to decide which one, based on if that slope is positive or negative. In this side example here, it was positive. The predicted y will increase or decrease by whatever that slope is. Okay, so I'm going to put some squigglies here about which you need to put in context. Okay, but that's kind of the general idea. As x goes up by 1, predicted y changes according to the slope. So in our example, we could say something like this. As yolks increase by 1. Okay, it's not really units, it's 1 egg yolk. The predicted, and in this case y, is our amount of cholesterol. So the predicted cholesterol will, think about carefully, we're going to choose increase or decrease. Hopefully you're thinking increase because our slope is positive. So the predicted amount of cholesterol will increase, again because the slope is positive, by 23.8902 milligrams. Okay, so it's our in-context way of saying as x goes up by 1, the predicted y will change according to the slope. All right, let's try interpreting the intercept. So interpreting the intercept, notice the intercept here is 1. And I get the intercept of 1 for my predicted value when I plug in 0 for x. That second term goes away and I'm left with the predicted value is 1. So our interpretation here, we could say something like when x is 0, okay, so when I plug in 0 for x, the predicted y, again, important to have that word, is whatever that y-intercept is. Again, include the units for the particular problem. So in our particular example, when x is 0 means we have no egg yolks, 0 egg yolks. So I'll say when there are no yolks, okay, that's my way of saying when x is 0, when there are no yolks, the predicted y, and in this case y is measuring cholesterol, is, and our y-intercept in this problem, if you're looking maybe closer to the top of your page, was that 12.2095 milligrams. So when we have no egg yolks, our predicted cholesterol is 12-ish milligrams. Make sure you know these. Again, if you're a highlighter type person, maybe these general interpretations will help you as you're working through your practice problems. All right, let's talk about one last topic on here before we pause for our second example. So for this particular topic, we're talking about this value of r squared. R squared is called the coefficient of determination, and it really is as simple as taking correlation r and squaring it. When we do this, we get some useful information. You'll see emphasized here in your notes, it's telling us the portion of variability in y, or our response, that's explained by our line. So this is an important idea to think of. Remember, if we had correlation was between -1 and 1, and if we squared that, we would expect it to be, remember when we square negative numbers, now they're all positive, so we'd expect it to be between 0 and 1. I was giving away my answer earlier. Here, remember, if -1 meant I had a perfect line with a negative slope, so that's telling me that relationship is perfect, and if I square -1, I get 1. Here, perfect line with a positive slope. If I square 1, I still get 1. So this closer to 1 I am, the closer to a perfect relationship I have, or 100% of the variability is explained by my line. If I'm closer to 0, then that's saying my line's not doing such a good job. Closer to 0% of the variation is explained by my line. So this is important because we can always do the math and calculate a regression line, but we want to know, is it useful for interpretation? Is the relationship strong enough to make interpretations and predictions based off of? So here, let's calculate and interpret r squared for our data set. So in this case, our correlation that we had prior was 0.8328. If we square that, don't multiply by 2, but actually square it, you should get 0.6936. And this is telling us that 69.36% of the variation in cholesterol, or our y variable, can be explained by the line. And since that's pretty high, it's closer to the 100% end of the spectrum than the 0% of the spectrum, we would say we feel pretty comfortable using our line for predictions. How high this has to be kind of depends on the discipline. But again, generally we want it closer to the 100% than the 0%. Some people use 60% as a cutoff. That's a very general guideline. Again, depends on the discipline. All right, I would suggest trying the second example, working through these questions again on your own, then watch the next video to check and see how you did.